Thank you for giving me the opportunity to deliver my intervention, which talk about piezoelectric property of word size structure, a first principle study. So I will start my intervention with a plan of the presentation, which will begin with a general introduction and the piezoelectric property of material. Also, we will talk about the method and the calculation used in this presentation. Also, I will briefly talk about the result and discussion them. Finally, I will finish by making a summary of our work and result. So, to this day, the integrated piezoelectric occupies all the aspects of our model life, which a common phenomenon of mechanical energy converted to electrical energy and vice versa. So the use of piezoelectric material today cover a range of important applications in our life, including medical, industrial, and ultrasound, especially ultrasound transducer. Currently, the most piezoelectric material used in the application are lead zircon and titanium due to high piezoelectric coefficient and dielectric permitted also the coupling factor. But due to a large amount of lead due to high toxicity, the research scientific are focused in the development of alternative lead-free piezoelectric material that can replace it that can replace the use of lead zircon and titanium of material. One of this most studied familiar is the word side structure material. So today we will talk about lanthanum nitride as our word side structure. So the word side structure belong to a hexagonal crystal system. Also, there are 4 atoms per unit cell. Also, the word side structure are non-centrosymmetric, which means have a band gap semiconductor with a high piezoelectric effect. Calculation method and tool used. So in our calculation, in order to study most of property of word side structure, we use a first principle study based on density functional theory and density functional perturbation theory (DFPT). So APNet provides option for the simulation, dynamic and dynamic matrix generation, born effective, elastic, and piezoelectric property. The exchange correlation used are the generalized gradient approximation GGA, also the local density for the approximation LDA. So before we start our calculation, we have to do the test of the convergence. So we use a very high plane with energy cutoff or energy of copper energy to 60 to 50 heart rate. Also, we use a high value of K point 10 by 10 by 10. Also, the convergence of the total energy is a very important, which less than 0.1 millirad. Result and discussion. So we start with the structural property of quartzite lanthanum nitride. So to obtain the equilibrium value of the lattice parameter and the real position of the atom quartzite lanthanum nitride, the full relaxation of the pressure and force must be done using the optical variable configured with the APNet code. So in this table we present the calculated parameter A and C and internal parameter, also bulk modulus and pressure derivative. So our calculation in good agreement with the result available calculation. Also, the bulk modulus and pressure derivative, our LDR, result in a good agreement with the calculation method. Electronic property. So the calculate of the electronic property are very important, which you have to know the nature of material. So our calculation with GGA and GAA are depicted in the figure. Of the Fermi level is set to zero and indicated by horizontal data line. The band gap calculated with GGA is 1.05 electron volt, which about 5t larger than LDA. Also, our compound exhibits a semiconductor behavior with indirect band gap with LDA and GGA. The oh la la. Now we focus on the piezoelectric property. So before we show, we have to show before we show the result of our calculation in the piezoelectric, we have to know the piezoelectric effect. So the piezoelectric effect is a property of certain crystal which acquire polarization and the effect of the mechanical force. And the reverse property also exists. So when applied electric field occurs the deformation or tension of material. So the most common carried are the macroscopic point view. So in our calculation we use the calculation by mean the linear response calculation, second derivative of the strain and multiplication in the electric field. The property of response to a microscopic and static electric field can be calculated with the DFPT. So our compound crystals in the wet side structure have three separate piezoelectric tensor: E33, E31, E50. So also we have to piezoelectric we have the dielectric and converse piezoelectric constant. So our calculation for the piezoelectric property of our compound are shown in the table. So we note that our calculation per GGA are higher than are smaller than LDA, which the understem or overstem by the approximation. Also, we note the counted U and D indicated the higher value than determined by GGA obtained by LDA. The difference observed between the two approaches with the respect to the constant D result from the estimation of the elastic constant, which turn depend on the volume of the unit cell. So our piezoelectric constant has a large effective constant piezoelectric value D that enabled effectively to count with the zinc oxide and lanthanum nitride and aluminum nitride. So our compounds are very good candidate for the application medical. So we finish by our conclusion that we use it that in this presentation we use the first principle method to calculate the structural electronic elastic piezoelectric and property of material. So the piezoelectric property shown a high value and important coefficient piezoelectric constant, especially the direct constant A33 and the converse D33, which can replace by PZT to avoid the high toxicity. So the piezoelectric and mechanical results are useful for the demand device, especially the ultrasonic transducer.